Hi everyone, I'm Gizéh Rangel-de and I'm going to present Digital Bioarchaeology of Artificial Head Shaping, a case study in pre-Columbian crania from Cuba and Peru. A project that I have developed in collaboration with my colleagues Adrián Martínez Fernández, Armando Rangel Rivero, and Alfonso Benito Calvo. Artificial cranial modification was a widespread practice in the Americas at the time of the European contact. The Spanish chronicled intentional head shaping among the native population, including the techniques and material use. Previous research indicates the cranial modification was performed after birth and lasts through early childhood, when the cranial bones are still flexible and easier to manipulate. For example, for the frontal occipital tabular cranial modification, the head was tightly encircled with bandage and secured between two boards, one on the occipital bone and the other on the frontal. The anterior-posterior mechanical force applied resulted in a head with flattened parallel orientation and backward inclination. Whereas for the annular modification, bandage, bands, or straps were used to compress the skull around the head, giving in some cases a cylindrical appearance. The pressure and tension applied during cranial modification induced functional and structural changes between soft and hard tissues, which means bone, brain, and vessels. Nowadays, many museums are the guardian of valuable bioarchaeological material from pre-Columbian and colonial times, including head-shaped samples. That is the case of the priceless collection held by the Anthropological Museum Montané at the University of Havana in Cuba. The Museum Montané was founded at the beginning of the 20th century in Havana, Cuba. Since then, the museum has become an important research institution in the Caribbean. The collections held by the Museum Montané result from more than a century of continuous work of professionals, antiquarians, and amateurs. This institution was created in a period when many museums, scientific societies, and royal academies were established. In general terms, the 19th and the beginning of the 20th century are critical in the study of archaeology and anthropology, because it is when these disciplines grew into a more systematic and modern way. Currently, many museums want to digitize their collections to include multiple forms of digital media and 3D resources, which positively impact the preservation, access, and management of these collections, and also foster engagement with visitors, stimulate new forms of learning and research, and revalorize the exhibits, among others. The use of 3D method for documenting cultural and natural heritage has been widely validated in recent years. Digitizing archaeological, anthropological, or other cultural heritage collections means preserving them for future generations. The creation of 3D models serves to highlight not only the tangible collection it represents, but also the intangible resources associated with the object, such as tradition, stories, myths, and legends. In this study, our main goals were the application of 3D techniques to obtain reality-based models of key pre-Columbian crania from the Anthropological Museum Montané, and to use the 3D models generated to produce 3D prints and animated videos. A representative selection of the unique pre-Columbian crania from the Museum Montané was used in the current study. 8 crania were collected in Cuba, and 3 crania were recovered in Peru and donated to the museum at the beginning of the 20th century. This collection was selected for its anthropological, archaeological, and historical importance. The specimens were sufficiently preserved and documentation, including the name of the collector, recovery site, and date, were available. All the specimens were scanned using the ARTEC Space Spider structured blue light scanner, and the scans were processed using ARTEC Studio 11. The scanner ARTEC Space Spider can achieve a sub-millimetric 3D resolution and point accuracy in the final model up to 100 microns and 50 microns respectively. All the specimens were digitalized following the same method. Each specimen was placed on a rotatory platform and scanned in different positions to register the cranial hole geometry and texture. This process resulted in almost all cases in 3 scans per specimen and a capture of 100 frames per scan. High-density polyurethane foam support was used to stabilize and immobilize the skull when the position required it. Each capture was made at a distance of about 20 to 30 centimeters, and the time of capture of each cranium was between 5 and 15 minutes. First, a fine registration was run to align the scans captured on each specimen. Then, the auto-alignment tool was used to match the overlap scan in the same 3D space. The aligned scans were then registered globally to compare and optimize the frame position across all the scans. Once the global registration was completed, a maximum registration error of 100 microns was obtained, proving the high quality of the registration. Then, the outliers were removed to clean up possible noise in the final model. For better results, a resolution equal to the maximum registration error of 100 microns was applied. Afterward, the sharp fusion tool was used to fuse all the scans and create a single mesh. Finally, a texture was applied to the final model to obtain a realistic appearance. The resulting high-quality meshes were exported in mesh and texture formats. 3D models were printed at 1:1 scale using FDM technology and PLA material. The 3D animations were produced as high-definition video. For example, here we can see a fragment of the video including the skull recovered by Miguel Rodríguez Ferrer at the end of the 19th century. Here we present for the first time a study with systematic and reliable results based on the use of digital techniques to reconstruct the valuable specimens of the pre-Hispanic crania collection from the Anthropological Museum Montane, in this case specifically the artificially modified crania. All the 3D resources created will encourage new knowledge through research. Also will provide broader access to these pre-Columbian crania collections through a variety of learning and outreach activities. The 3D structural light scanner used was a fast method that allowed us to obtain detailed 3D models reproducing the original cranial geometry and texture. Specific features such as fractures and foramina were easily identified in the models. No method is without drawbacks. Some structures, such as the orbital part of the frontal bone, the lacrimal, and the vomer, when present, its acquisition was challenging but possible. Here you can see one of the videos created for educative and outreach purpose. The video displayed the 3D model of the cranium recovered by Carlos de la Torre at the end of the 19th century in Cuba. The 3D models created are ready to be examined using 3D viewers and further edited using 3D modeling software. Many processes can be performed using the 3D models and software package, such as computing measurements on the digital surface, viewing them and manipulating the specimen from any chosen angle to reveal in detail specific features that may be elusive in the physical sample. By simplifying the meshes, we found a trade-off between producing a satisfactory recognition of the cranial structures and decreasing the computation load on the software used, which could be problematic on lower power devices. 3D textures rendering in models and video give a sensation of reality, allowing researchers, students, and visitors to visualize the different bone structures visually. Please feel free to scan the QR display in the corner of the screen to check out the full videos created. The significance of digitalizing this specimen goes beyond the creation of 3D models. It means protecting this fragile and valuable collection for future generations. The methodology and the results reported here can be used in other museums with similar collection for its documentation, study, protection, and dissemination. In the future, we seek to continue exploring the application of novel methods and digital techniques to the study of pre-Columbian crania collections. The results presented here has been recently published. Please feel free to check out the papers and contact us if you have any questions or comments. We want to thank the organizers for hosting this virtual conference, and also we want to thank the support provided by the Digital Mapping and 3D Analysis Laboratory at CENIE and the Anthropological Museum Montane and our hosting institutions. And these are the faces behind the project. Thank you so much for your attention, and please, if you have any comments or questions, feel free to contact me.